Now let's talk about a coordinate bond. We have talked about ionic bond and covalent bond. Now let's see what is a coordinate bond. Coordinate bond is also a type of covalent bond itself, but let's see what is a coordinate bond. So coordinate bonds are a special kind of covalent bond, okay, in which both the electrons in a bond are donated by a single atom. That means what? The one atom donate both the electron to the other atom. So let's see some of the examples of coordinate bonds. So in coordinate bond formation, one atom has to accept electrons. Obviously, if one is donating and if other does not accept those electrons, there will be no bond formation. So in coordinate bond, one donates electron and one has to accept the electron. And now here comes your Lewis base and Lewis acid theory. What does you mean by Lewis acid? Lewis acid is the one which accepts the lone pair of electron, and Lewis base is the one which donates the lone pair of electron. So the one which accepts the electron is acting as a Lewis acid, and the atom must have an empty orbital. Then only it will accept the electron, correct? If it does not have any empty orbital, how will it will form a bond? So look at this example. Here you can see we have taken A and B. Okay, here A itself is donating both the electrons to B and forming a covalent molecule with coordinate covalent bond. So similarly, you have a NH3 over here. Let's consider this reaction where your BF3, which is your electron deficient, and your NH3, which contains a lone pair, are now reacting. So NH3 has lone pair of electrons. So this NH3 will donate the lone pair of electron to the boron. The nitrogen donates the lone pair of electron to the boron, and boron has an empty orbital, and that empty orbital accepts the electron, forms a coordinate covalent bond. So here your NH3 is donating electrons. So your NH3 will act as a Lewis base. Your BF3 will act as a Lewis acid. And the compound, the molecule which is formed is known as Lewis adduct. Correct? So here NH3 act as a Lewis base, donates lone pair to empty p orbital of boron and form a coordinate bond. Now let's look at the other example. Now these are your bulky Lewis acid and Lewis base. Here PR3 and PBr3. Okay, we have PR3 and PBr3. They cannot form, we have PR3 and PBr3, they cannot form a bond. Why? Because the R group, which is an alkyl group, is already a bulky group. Here you can see in your reaction, the R group is already a bulky group. Bulky group means what? There will be a steric hindrance. The group is very large in size. Similarly, you have PBr3 here also. You do not have a small compound. Here also you have a bulkier group. So what will happen? It cannot donate electron. The other one cannot accept electron. So it cannot form a coordinate covalent bond. Now let's take a simple example of H2O and H+. You can see on your screen you have H2O, water molecule, and a H+, that is your proton. Now H2O contains your oxygen of water molecule contains a lone pair electron, isn't it? So this lone pair of electron is donated to the H+, as you can see on your screen, and what we get? We get a hydronium ion. So now we can say that your water molecule is acting as a Lewis base. Your water molecule is acting as a Lewis base, and your H+ is acting as a Lewis acid. And your hydronium ion is your Lewis adduct. Your hydronium ion is your Lewis adduct, which forms a coordinate covalent bond. So here H2O act as a Lewis base, donates lone pair to the empty s orbital of H+ and form a coordinate bond. I hope the coordination bond is clear to you, and in this session we will end with here, but in the next session we will look at the properties of covalent compounds.